Welcome to Meteor Interviews, a series of interviews with Meteor developers, community, and core team members. Today I'm speaking with Arunoda Susiripala. Arunoda is the founder of Khedira, the performance and error monitoring service for Meteor. He runs Meteor Hacks, and he's by far the most prolific contributor to the Meteor community. He's written more Meteor packages than I can name, but I'm sure we'll talk about some of the main ones today. He has written Pro Meteor and the Bulletproof Meteor online course. Arunoda has a lot of experience with scaling large production Meteor apps because of scaling Khedira itself, and because Khedira is actually a tool for diagnosing performance and scaling bottlenecks. So one of the first questions I always get when talking about Meteor is about scaling. So my goal for today is to learn more about scaling Meteor apps. But first, Arunoda, the question on everyone's mind is how you manage to do so much. So I have to ask, do you sleep?
Yeah, of course I sleep.
Okay, good. I just wanted to make sure. All right, so can you tell me what Khedira does?
Okay, Kardi is a performance monitoring solution. So it's basically tracks what's happening in your application, and then we'll show you how things gonna work, or how things works in the application, and you can see with our online dashboard, and then you can fix accordingly with the information.
So you can see what your app's doing in production, see how long everything is taking, get some alerts when things are certain things are taking too long, or when errors occur, things like that. Awesome. So so Khedira is a great tool to help you see what's going wrong with your app in production and help you scale it. So I think maybe we should talk about some terminology a little bit just to get things out of the way. So there's a distinction between scalability and performance. So do you want to talk about that a little bit?
Oh yes, it's very hard to. Yeah, I think both scalability and performance, both are something goes in connection, but I think it's two different things. That means we can add more servers, but that doesn't mean our application is performing better. So
Right.
you need to think about how to improve our app in the first place, and then after that we can scale.
Right. So something might be fast, but not necessarily scalable.
Yeah.
But it's only really a scalable architecture if you can, say, add, double the servers to get double the throughput.
Yeah. But again, I add more stuff to this. Some people think like that means scaling is simply using Nginx or simply adding more servers, but actually it's not like that. Scaling is built into your application and framework, so you need to tune what other stuff you need to configure and so on. So it's a whole lot of process. It's not just simply adding more servers.
Mm-hmm.
That's the thing.
Right. So your application and architecture has a lot of effect on scaling and on whether you'll be able to scale, and same with your choice of framework. So what bottlenecks would a typical Meteor app run into in scaling?
So the main bottleneck is the CPU, because for the whole the TDP stuff, there's mainly on the server. There's something called merge box. The merge box is something like that means we have a cache kind of thing on the server for all the data on the client, and then it will check also stuff with the data. So that's one thing, and that's for the observers, and also it's very CPU intensive sometimes. And recently there's some question about the oplog. So that means when you're having a lot of updates on your MongoDB server, those data will be trying to come into your Mongo application Meteor app as well. So then there's some problems with that one also.
Right.
So the main bottleneck is CPU.
So usually it'll be CPU, and so you mentioned two things there. One is that a Meteor app is listening on the oplog from MongoDB, and you might get a lot of writes.
Yes.
So let's explain that a little bit for anybody that might not know what that means.
Okay, so that means normally Meteor is trying to do how Meteor do the real time stuff is basically listening to the oplog. So oplog is a kind of like all your write operations is kind of log, but having all the write operation in MongoDB. So Meteor normally get those changes, and if you're having a lot of write operations, so all those changes come into your application. But Meteor is not MongoDB, so it's for a different purpose. So then it can't handle that load.
Okay, so MongoDB is sending out the op log, which is all of the write operations, so all the changes to the database. Meteor is listening on that, and because it has to consume all of that input, that can be a major, I guess, taxing on the CPU.
Yeah.
Okay. So, I think you touched on something else there. So, like, Meteor is kind of different from other frameworks because it keeps state for each connected client. So what about memory then?
Memories is not something we need to worry, because inside Node.js, so it will try to cache all your data. That means if you're having even if you have multiple copies of your data, but actually inside the Node.js framework will be maintaining your data, and so there won't be much problem with that. So the biggest problem is CPU.
Okay, so even though you're pretty much caching every data set that every client has, it's usually doesn't end up being a big problem. Okay.
But if you are having, let's say, if you're sending like 10,000, maybe 100, like huge number of data to the client, so there'll be a problem. But normally, so it won't happen.
So if you're not doing anything crazy and you're not sending a huge amount, if the subscriptions, if the publications that you're sending to the clients are not sending thousands and thousands of records, then normally you should be okay with memory. Okay.
Yeah.
Okay, and that's good to know.
If you're sending thousands of documents to the clients, then that means you need to change something.
Okay.
Because sending thousands of documents is not something gonna work.
No, totally. And you're gonna have performance problems in every client as well.
Yeah.
Yeah. Okay, that makes sense. And even if you did run into those kind of problems, I guess that would be something you could solve by just adding more servers, right? Because you'll just spread the clients across more servers.
Yeah, maybe.
Okay, so let's talk about the op log and the CPU then a little bit more. I know you guys have done some things like I know. So Khedira receives tons of events from every app that's using Khedira to monitor it.
Okay.
So you've got an enormous amount of writes going through. So what have you done? How do you solve that problem for Khedira?
Actually, with Khedira, we are not accepting the data with Meteor. So we're having a separate Node server.
Yep.
We accept all the metrics, and we send it to a different Mongo database. And right now, we are working on moving our Mongo to Cassandra. Okay. So that means that's our current plan. So basically, we are having a separate MongoDB for the metrics, and for all the user information and all the app information is stored on a different database. So then our matrix does not clash with our normal data. So you don't have that problem.
Okay. So all the writes that are coming in, all the metrics that are coming in from all the apps, like everything that they're measuring, it's not going into the same MongoDB that the Khedira app is using, because if it did, every instance of your Khedira app would have to process all of those writes, and it would overwhelm it. Okay, that's cool. So that's something that we could keep in mind. If you've got that seems like something that the typical app would not necessarily be able to do, though. I mean, you've got all this metric data that you can maybe post-process and deal with it that way.
Yes.
So what would you do if you did have an app where the situation was that maybe it's like you're starting to scale and you've got legitimately enough write data to your app's data that it is starting to cause problems on the CPU on all of your instances. What do you do?
Okay, that means that normally the problem comes with when you are getting data from somewhere else. That means you are directly ingesting the data to the MongoDB, then there will be problems. So if you're having some kind of the situation, so then the only working solution right now is to trying to move those data into another DB, and then you can connect to that DB using Meteor, and then you can do all the normal operations like getting documents and even creating cursors like using in the publications. But you can't use uplog. So that's the thing. So you need to basically separate those collections into a different database and then trying to connect with another connection.
Okay, so use a different connection. But if you're
Yeah.
not using oplog, then what are you doing? Like
Actually, yeah, when we are not using uplog, it will try to poll
Right.
for every 10 seconds. I think every 10 seconds or every write operations.
Right.
So then that's the normal behavior.
So you would separate some of your collections, the ones with too many writes, you would put those on a different use a different DDP connection or a different Mongo server.
No, it's not a different DDP connection. That means inside your same application, you're trying to connect to a different database.
Okay.
Different Mongo database.
Different Mongo database, and that database you're not using the oplog. You're just falling back to the old way that Meteor did things, which is just polling every 10 seconds. Okay.
Yes.
All right. And so I think Meteor recently added something to automatically fall back to polling if the oplog reads are falling too far behind.
Yeah, I think I have seen the commits, but I haven't tried that yet. Maybe something to try.
Okay. So that might help, but you might end up in a situation where your CPU is just out of control even before that happens anyway, I guess.
Yeah.
Okay, interesting. Cool. Okay, so what about MongoDB itself? So like what about write traffic?
Right. Actually we did a
Sorry, I'm sorry. I meant to say what about read traffic, but I guess it's both applicable. So
you mean for the which like
I mean the Mongo server itself. So
I think Mongo is kind of okay for the reads, but if you're not using something like MapReduce or kind of thing, so the Mongo is quite okay. We have aggregation of pipelines. I think Mongo is quite good for reading, but the problems comes for the writing stuff. So it's normally so it's very hard to write. That means it's not something common to the MongoDB for all the other stuff. But I'm assuming that there are more writes than reads. So that's for our use case.
Okay. So and is that because you said you wouldn't really have trouble with reads? Is that because you would just add more slave servers to read from?
No, actually, I think for the Khedira use case, because we don't have much reads, because normally so every day, every time, so people sending, so the app is sending traffic to our servers, but you're not logging into your app, Khedira app every time. So that's the thing. So,
okay. And so if you do start to overwhelm MongoDB with writes, then what would you do?
Then actually we try to use the recent Biot Tiger, the MongoDB 3.0. So it can handle like quite big amount of write operations, but after some point, so it will try to like you can't control that one. That means for an example, we try to get around like 4,000 write operations per second, and then the CPU usage is around like 250%. So we're having a server with 4 cores, and then after the 4,500 kind of rate, and then the CPU maxed out. I think there's something kind of internal stuff. So still it's not like highly scalable, but for the normally, I think the WireTiger is something good.
Okay, so you guys are using WireTiger, the new engine in MongoDB 3.0.
Actually, we try to use that one, but actually that can't meet our demand. Actually, we're trying to scale the platform, so actually we moved to the Cassandra.
Okay, so now you're switching to Cassandra for the metrics data only.
Only metrics data.
Okay, And your app is still using MongoDB.
Yeah.
Right.
I think for this our use case is something is different. Like we have a lot of writes than reads.
Right. Okay, interesting. Cool. Okay. So how about deployment? So I mean, and specifically related to scaling. So what do you have to think about for a typical Meteor app when you're choosing hosting and when you're deploying it?
Right. If you're choosing some kind of deployment, so normally try to get something like more than 512 MB RAM, maybe 1 gig RAM.
Yeah.
But so you don't need to get something RAM around 2 gig or maybe after 3. Like so, normally 1 gig RAM is more than enough.
Mm-hmm.
And for the server, I think if you can get a like normally, I can't say the number, but if you have a very good CPU is high CPU, then try to get that one.
Mm-hmm.
Then recently we have added the with the cluster package. Now you can use the multiple cores as well, so you can get that benefit as well.
Okay, yeah. Let's talk about the cluster package. So Node is single threaded. It can handle it uses evented I/O, so you can handle lots of requests at the same time, but it can really only make use of one core or one CPU, right?
Yeah.
So let's talk about that. How do you solve that?
Okay. Normally in the Node world, so we're having a Node cluster module, but so Node cluster works is like it will try to send all your incoming traffic into different workers. That means in your core for each and every core. Now the problem is this we can't get this sticky session support with this cluster module. So actually we have written our own version for the Meteor.
Yeah.
So then it will work with all the like sticky session and everything. Okay. So that's the cluster package does.
Right. So you need sticky sessions. So if you've got multiple node, if you have multiple node instances or multiple servers, sticky sessions means every request from a particular client has to go back to the same server. So one client can't be making HTTP requests to different servers.
And I think I need to add something. That means it doesn't not necessarily always each and every server. That means individual cores actually you're running a worker. So actually you need to have a sticky session support for those individual cores as well.
Right. Yeah. So you have to make sure that each client is hitting the exact same Meteor instance, right?
Yeah. Yes.
Yeah. That was actually something that you reminded me of on the Meteor forums thread about Heroku. So if you've got WebSocket support, that's not going to be a problem. But because Meteor uses sock.js and it falls back to HTTP polling, that actually means that and the Meteor, this is kind of like at a lower level than the Meteor server itself. It doesn't realize that you're one long. It just thinks you're doing one long connected session. And if sock.js is actually trying to hit different servers underneath, then that causes a problem. So the sticky session thing is super important. So you wrote the cluster package, and that's just a package that you just add to your Meteor app, and then you run multiple instances of it. Can you explain a little bit how you use it?
Yeah. Okay. Cluster is actually we build cluster for basically now we need to scale with the application. Then we need to install Nginx like kind of proxy in between all the servers. But we need to make that simple. That means then you don't need to install Nginx to do all the scaling. So we build this cluster package. That means it's a package actually do all the like proxying kind of thing. But actually we did something smart. Actually now with the cluster package, you don't need to use a proxy. That means inside your application there won't be having any proxy thing. So you're directly from the browser you're connecting directly from the browser to the individual servers. But actually you don't need to configure for that one. it will try to do automatically all the stuff. So then if you need to add more servers, simply add more servers. Then cluster package will coordinate how to connect like all the stuff.
Okay, so do you mean that you would not use Nginx? You would just use the cluster package instead of
Yeah,
proxying through Nginx.
yeah,
Okay,
yes.
right.
Actually, you need to use Nginx for if you want to use like SSL or kind of thing. But actually, so it's better to use something like start or bud to terminate a SSL rather than using Nginx in this case.
What is that? I'm not familiar with it.
Oh, okay. Normally, so if you need to terminate SSL, that means Node is not a right tool to do SSL stuff. Then there are some tools that we can put in front of our Node server.
Okay, so it's just an SSL proxy, basically.
Yes.
So you install your certs on this proxy. It terminates the SSL connection and then proxies to your Meteor app behind it. Okay, so you would recommend that instead of something like Nginx.
Yes.
And then you use the cluster package to make sure that you're connecting to multiple instances of Meteor. Okay, and then
I think so. What I'm trying to show you that means so of course we can use Nginx. The cluster package is something simple to use. So the performance actually we can't compare with the Nginx and the cluster because how cluster work is something very different. Nginx is trying to proxy every request, but cluster is not trying to do that one, trying to avoid that proxying thing.
Right. So how does it work? You hit one. If you have a proxy, maybe your SSL termination, whatever. I'm sorry, I didn't catch the name of the thing you just mentioned, but it's terminating your SSL. It's sending the requests to one of your Meteor instances, and then what happens?
Yeah, that means we are putting the SSL terminator in front of your each and every Meteor instance. That means it is put inside each and every Meteor applications. So that's the thing.
Okay, so it runs. Yeah. Oh, so this is actually like a Meteor package. It's not a separate process.
No. It's not a Meteor package. Actually, it's a separate process called STUD. STUUD.
STUD. Okay.
Yeah, and there's another one called BUD. But it's something new.
Okay.
So they're kind of different processes trying to terminate the SSL and forward the request to the app.
Okay. So it's a separate process. So STUD forwards the request to your Meteor app.
Yeah.
And does it forward to one of your Meteor instances? Or
actually,
all of them?
We put STUD in front of each and every application.
Okay.
Yeah.
So if you have multiple Meteor instances on one server, then you would have multiple.
If you have multiple, like if you need to have a SSL support, I think then we need to do something tricky. So we need to start in different ports.
Okay.
It's something possible, but.
Okay, cool. Okay. I think I get it. And then so the cluster package helps to spread the connections out among all of your different Meteor servers. Okay.
Yeah.
Okay, so. Sometimes one of the reasons why people add Nginx is for proxy is for static assets, for example.
Yeah.
So what do you recommend about that?
I think yes, of course. So trying to serve this thing is not kind of work. I think it should work, but I think having a CDN is something simple.
Okay, so you would add a CDN, a content delivery network. And so what do you need to do? You've talked about using CloudFlare. What do you need to do to add something like that to a typical Meteor app?
Okay, CloudFlare is a very easy way to have kind of CDN kind of thing. And I think if you need to use CloudFlare, so then you can't have WebSocket support. So then the only thing you need to do is turn off the WebSockets support in your application. So for that one, you need to pass a single environment variable. And after that, you can have the CloudFlare support as normally you would do with the normal application.
Okay. So And what do you do in your app to make it so that all of the URLs for your assets go through the Cloudflare uh, to the Cloudflare servers instead of to yours?
I think it's very simple. So inside the Cloudflare server, Cloudflare
Yeah.
app, then you need to put your IP address for the your server, and then and there's a small icon on the to enable Cloudflare support for
Right.
that DNS record. It's simple. It's just
Okay, so
normal.
you point your DNS to Cloudflare, then you
Yeah,
configure Cloudflare. You tell Cloudflare
yeah,
where to find your app, which is going to be a private location, and then
yeah,
Cloudflare just rewrites everything.
yeah. And if you use WebSocket with Cloudflare,
Yeah.
and there's a where you can do that one, because you can add a new DNS entry, and you don't need to make this DNS entry goes to the Cloudflare. That means you can turn off the Cloudflare support for that entry, and then you can use that URL for the your all the DDP traffic.
So okay, so do you mean the DDP traffic goes directly back to your server, or it's proxied
Yeah,
through
yeah,
Cloudflare?
yeah,
Okay.
yeah.
Okay, so it's
So there's some
directly.
proxy too. Yeah.
It's not proxied.
Yes.
Okay, so it goes directly back to your app.
Yes. I
So
think I did a blog post on how to do these things. I think
right.
if you just search for the Cloudflare and Meteor,
Okay.
and you'll get to see this stuff.
Okay. Cool. So then that brings me to another question, which is about Sika.
Okay.
So DDP and denial of service type attacks. So you wrote a
Okay.
package that can help protect against that.
Yeah.
Can you
I
tell us
think
about it?
yeah. I think that's the start actually we built. So it's a kind of proof of concept,
Okay.
like how to protect our apps against those attacks. So basically, what Seeker does is try to monitor the IP addresses, how they sending traffic in the so we monitor the traffic in the DDP level.
Hmm.
So then if we're trying to see any kind of like problem, so someone sending too much of traffic, so then we prompt that one with the kind of captcha page, and then we will block that IP address sending or other traffic. So basically it works right now, so we don't sure that it's kind of scalable solution or not, but it's working right now. So our plan is to they have a huge plan to work on that one and trying to improve a lot on this area.
Okay. Cool. Okay. So I guess with scaling Meteor apps in general, do you think is it like a known is everything known? Is it just a matter of when you start scaling, you're going to hit certain known bottlenecks, and there are other people that have hit these things like
Yeah,
many times before, and they'll just tell you exactly
yeah,
what to do? You think so?
yeah. I think there are some problems for the scaling. I think that's true with other platforms as well.
Hmm.
So now with Meteor, you are trying to do everything real time. So there's some cost for that one. So basically, I think all the problems are known right now. So there are some tricks we can do trying to get rid of those problems. I think it's not something scary, but we have solutions.
Okay. So there's pretty much a known solution for every type of thing you're going to hit. And
Yeah.
so at what level are you going to hit these types of issues where you have to start doing workarounds or
Uh,
changing your architecture? Like how many concurrent clients would you start to worry?
I think that's the hardest questions to answer,
Hmm.
because we can have like 10 concurrent clients, and we can simply take down a server.
Right.
So actually we can have one concurrent connection and take down a server. That means take down all the CPU. So
Hmm.
it's completely depend on how you wrote your application
Right. Of
and
course.
how do you that one.
Of course. Yeah. I
Yeah.
mean, of course, it depends on your app. You could be doing something crazy,
Yeah.
but I mean,
And
like what typical. Okay, maybe I'll ask a different question then.
okay.
So what type of scale are are there any big public apps that have made this data available publicly about how many concurrent users they're trying to that
Uh,
they're successfully serving?
Actually, I haven't heard any official information on public, but
Okay.
I have seen on the somewhere else like classcraft.com.
Hmm.
They are doing serving around 6,000 concurrent connection, but I'm not sure that it's something true or not.
Hmm.
But I think that's something possible.
Okay.
So yeah, actually we did a load test serving around I think like 20,000 concurrent connection with Meteor to just to load test the our cluster package.
Hmm.
So basically it's possible. It's not something you can't
Okay.
do.
Okay. So you shouldn't be too worried if you're planning to build a Meteor app that's got to serve thousands of concurrent connections. Definitely possible. Yeah. Okay. Awesome. Good. Okay. So, and then is there anything unusual that you should like try that you should watch out for? Like, are there any? I mean, you guys with obviously Khedira with all your metrics data coming in, that's something weird. But
Yeah.
what other types of unusual traffic patterns or unusual
Yeah.
types of usage
Yeah.
would be a problem?
Actually, there's a little problem with the so Meteor uses the fibers package to do all the like synchronous
Fibers.
kind of
Hmm.
fibers.
Yeah.
And there's also so when you're having a high amount of CPU usage,
Hmm.
and then fibers is trying to like is trying to queue stuff a lot.
Hmm.
And then if you're having so if you're having a lot of connections coming to the at the same time, so there will be some problems.
Hmm.
So that's number one. And next thing is when you're deploying your application, so that means if you're deploying for the app to the each and every server at once, and then all the clients try to connect again,
Hmm.
and then at that time your CPU will be increasing a lot.
Right.
So then the only solution is to try to deploy one by one.
Right. So
Once
okay.
ever.
So watch out for high CPU usage. I mean, I guess you want to make sure that you're not maxing out your CPU. Keep a lot of spare.
Yes,
Um,
of course.
and even though with a node app even those other types of node apps might be able to easily handle 10 or more thousand concurrent connections, because Meteor uses fibers, you might want to you might
Yeah, that's actually the second thing is not a problem with the fibers. Like
yeah
that means
two things. One is the rolling.
Yeah.
One is you want to make sure you do rolling restarts.
Yeah.
And so your first thing about let me come back to that in a second. And your first comment about fibers.
Yeah.
So because Meteor uses fibers for the async for managing asynchronous programming, so you're saying that there can be issues if the CPU is too overloaded.
I think not always.
Mm-hmm.
There are some cases that actually we have seen, like when you're having high throughput, then that means high CPU, then there'll be some kind of queuing thing, like every message is trying to queue. So
Okay.
I guess there's a problem with fibers package, but I'm not quite sure.
Okay.
We haven't digging into all the callers.
Okay, so in other words, just watch out for getting too maxed out on your CPU. Just try to keep lots of spare CPU capacity.
Yeah.
Okay, that's good.
Yes.
And then so you mentioned deploying and make sure that you do rolling restarts. So what you're saying is, if I understand this, I think what you mean is when you deploy, the Meteor server restarts all those queries that it's got cached in memory for all the connected clients. I guess it needs to requery
Yes.
those, and
Yeah.
that's going to temporarily spike your CPU.
Yes.
So make sure you've got some spare capacity. Don't restart all your servers at the same time. And I guess some of your connected clients will move off to some of the other servers while that one restarts. Okay.
Yeah.
All right. Cool. That makes sense. So if you do that, if you do rolling restarts, you might run into problems with your schema, for example. Like, how do you recommend? What do you suggest about that?
I think that's something really hard to answer, because I think with MongoDB, so we can have like flexible schemas. That means we can manage the schema in the code. That means we can say we can support the multiple schemas.
Yeah.
So I think it's a good idea to if you're not doing kind of like online schema updates, I think that's something you need to worry that you need to get rid of that one.
Just
and I think
Sorry, go
and
ahead.
there's some concept like 12 fact apps. So there are some concepts
the 12
you need to follow.
12 factor app, yeah.
I think if you follow those stuff, I think you don't need to worry much about that.
Right. Okay. So I guess what I meant was like, if you've got two different versions, if you're doing rolling restarts, you might have two different versions of your code, and if one of them is adding a new property on some Mongo document, and the other server is I guess adding won't be a problem, but if the two of them are expecting different structures of your data, you might run into problems. But so you're saying go look at the rules for 12-factor apps and make sure that you're not doing what was it? Was it just not doing online schema changes?
I think in your applications, then you can check whether your schema is up to the older one or the newer one, and then you can try to work like that one.
Right. Okay.
So it's something hard to do always, but it's the way how we can do actually. Right.
So only way. So make sure that your app can handle slightly different schema on different. Yeah. Make sure you can not. Make sure you don't do something bad if the schema is not exactly what you expect.
Yeah.
Okay.
And then if you're trying to change the schema, and then try to have a maintenance window, like try to inform all your clients. That means you're having an upgrade, and then try to do that offline.
Yeah. Okay. All right. Cool. So that's pretty good talk about scaling. I've learned a lot of stuff. Thank you. So, and I guess there's something that I wanted to ask you about, which is not really related to scaling, but you recently introduced a new router, so the Flow router. And so up until now, there's really been one router, which is Iron Router, that everybody uses. So what are the differences between Flow router and Iron Router, and what led you to implement a new router?
Actually, the reason we build Flow router is actually so we are seeing that Iron Router keeps slowing things down. Sometimes we're having re-renders kind of things. It's not something related to the Blaze, but sometimes with how Iron Router works actually. So then we try to change everything. So we try to think about React.js and trying to model those concepts back into the Meteor. And then Flow router is something part of that one. So actually we try to do. So basically Flow router is a router that actually simply do routing and subscription management. Mm-hmm. So that's only it does. It doesn't try to render the stuff into your screen.
Right. So it's more minimal. It just does it does subscriptions, but it doesn't it doesn't handle rendering for you. It leaves that. Well, I mean, let's talk a little bit about that. So you've actually got a Flow layout package.
Yeah.
So can you use that without Flow router? Is that something that you would really use on its own, or is it just kind of like a separate part of it?
I think we don't need to use a Flow layout directly. So if you're using Flow router, then you need to have a tool to render the template to the screen. Mm-hmm. So Flow layout manage that one. It will try to minimize the re-rendering stuff. Yeah, this thing.
Okay, so the biggest difference is, I mean, in general, it's more minimal than Iron Router, but it does not reactively re-render things.
Yes.
Okay. And so you mentioned something about React. I assume you're talking about React, the Facebook JavaScript front-end framework.
Yes.
And I've seen you've been doing some work with that. What do you think about it?
Actually, I haven't done any work with React recently, but maybe we tried once, but actually we're kind of okay with Blaze. But I think React is changing every way. We are trying to have it. We're trying to create application. And with React Native is completely different thing. I really like that one.
Yeah.
So it's something we need to think about. But actually, the React is planning for something like Relay and GraphQL. So basically, so that's something that means you can build a complete client-side application using all the React technologies. So then you don't need to use a Meteor for the client side. Totally.
Right.
Even for getting data, I think Facebook is trying to compete with kind of stuff. We need to look out for them.
Yeah, I mean, I wonder if I'm not sure that that React or any client side only framework could really be considered competing with Meteor. I mean, I think that it's just a matter of like embracing and working with the with other ecosystems, and I think Meteor, like people are proving right now that you can use Meteor with Angular and with React, and it's that they work well together.
Yeah, but the thing is that React actually they are building whole stack. So React is not about the React component thing. So they are working with something called GraphQL for all the querying, and then for the Relay to the to maintain latency compensation and all the stuff. So I think so it's something comparable with all the Meteor client side things. So that's the thing. It's something we need to worry.
Okay, interesting. Okay, cool. So, all right, that's awesome. Thanks. So, if our listeners would like to get hold of you, how can they do so?
I think you can tweet me at Arunoda, and yeah, that's the simplest thing.
Tweet you at Arunoda, so Arunoda. Awesome. And I would also say check out Meteor Hacks. Use Khedira in your app. I use it, and it's an amazing source of all kinds of valuable data that you wouldn't have got. Client-side errors, that kind of stuff. So, yeah, I'm a huge fan. Thank you for Khedira.
Okay, thanks.
And thanks for your time today, Arunoda. Thanks a lot.
Okay, sure.
It was great speaking with you.